the recording. All right, cool. So cool, no worries if you don't know latch. So latch is kundi. If in Hindi we call it kundi. I mean chatakni, whatever we can call it in different area, we call it different thing. See, this thing are latches, right? We use latch to close the door. These are latches. Is my screen visible?
Yeah.
Okay, so we use latch, right? I mean, and when I'm saying the latch, then latch will be closed, right? We have to open it. So if you add a latch in a door, that means we will close the door. Cool. So that's what I mean. Open latch does not make sense. Cool. So latch is okay. We haven't seen the definition. We move to this. So latch is a metal bar used to fasten the door or gate. Okay, cool. Okay, and type of lock for a door, right? So keep. Okay, key from outside. Cool. So now the latch, literal meaning of the latch is known, right, by everyone, right? Hello, am I?
Yeah.
Yeah.
All right. So the thing with the latch is, if I want to move ahead, then what I need to do in earlier, what were the issues that we faced when we were using multiple threads? In earlier examples, we had to use join, right? Let's take the same example, right? Okay, okay, this let's take the example of let's take the example of marriage we have taken right earlier, but with the marriage, is it completely workable with this? Okay, and then at last, okay, it's okay, it's not completely exactly, it's not going to cover all the cases that we had in the marriage. Let's take some other example. Okay, yes, one thing we can do. So let's say that we have a factory, and in our factory first we need to procure the potatoes, then we need to pack those potatoes, sorry, make chips of those potatoes, and then later on what we are going to do is uh, put those chips into the packets, right? Packaging part we are going to do. And when all these three tasks has been done or completed, then only my transport truck should leave, right? Am I audible?
Yeah, Abhishek.
All right. So the thing is, so now my work is to make sure that our worker, we want the end thing, right? We want procure the potato, potato, then the another thing will be make the chips, and then pack the chips, and then last thing is send the chips to the distributors. Now I just want to make sure that this thing should be done only and only if all three tasks has been completed, right?
Yeah.
Or rather, what we can do, I mean, this is again an example that the making chips should depend on potato, and then packing chips should be dependent on this thing. So instead of doing this, let's do one thing. Let's say that a single company create pack chips, and pack cola, and pack some other snack biscuits. Let's say biscuits. Cool. So now I want to take my consignments involved 3 items to deliver from a single factory. So I should leave for the distributor when I have all these three things, right? Now these things are not dependent on each other, right? So this is a little different example. Cool. Any doubts? How it is different from the earlier one and how it's different from the marriage example that we have taken? Like two people needs to meet and they need to agree to the marriage and those things that we have done. Hello.
Yeah, yeah.
All right. Cool. Just one more second. Cool. So let's write the code for this now. And all right. Just one more second. Cool. So these things we know already, right? How to write. So what we can do is simply, okay, let's write you using the join also. So the task you want to create, okay, the task. So runnable. So okay, here pack chips task and simple. Let's do chips. Okay, my bad. Chips. Okay, sys out. Let's do the sys out. Chips packed. And then the other thing is cola. And another thing is biscuits. All right, the three tasks we already have now. Now what we are going to do, we'll be using the threads for this case only. So okay, thread equals to new thread, and then pass the pack chips task, right? And then okay, pack chips. All right, one thing, and then I have to start it also, but later. First I'm going to create pack cola and pack biscuit. Okay, cool. So now what I'm going to do, pack chips dot start, pack cola dot start, and then pack biscuits dot start, right? Nothing new till now, right? I'm audible?
Yeah, yeah.
And then let's say okay, taking biscuits, chips, cola and biscuits to distributor. Cool. Now let's run it and then try to find what's the issue that we are going to face. The issue that we are facing, okay, have I used this? Okay, let's run it again. Cool. So the thing is chips was packed and this, why chips was packed? Okay, my bad. So cola and biscuits, my bad. Let me run it again. So now the thing is our biscuit was packed and cola was packed, right? But as soon as these two packed, all three has left, right? Is it possible? No, biscuit is not there, right? So we shouldn't leave. And if we run it multiple times, there might be a chance we leave first, right? Taking chips first when these things are not even packed, right? This is completely wrong, right? Hello, I'm audible?
Yeah, yeah.
All right, cool. So what are the things that we know how to fix this thing? One thing that we have already seen is simply use the join, right? What the join do, join will simply make sure that we wait until this code execute, right? This thread ends, right? Okay, not going to handle anything. All right, cool. So if I run it again now, anytime, regardless of how many times I run this code, I will be taking the chips at the last time only. Cool. Visible, 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 visible.
Yeah.
So this is the thing that we used earlier. What's the drawback of this code? Okay, packed chips is never used. Okay, my bad. I have to put it here. No. Okay, biscuits was two coming earlier was coming two times. Cool. So what's the drawback of the code that I have written? Why we should not write this code in the production in 2025? The thing is, we are using the thread object, right? And we are using start on it. It does not make sense to create the thread on it and then start. But the thing is, if we don't use it, then how can we make sure that we don't take our ship empty, right? Over here, earlier we were writing that we are leaving with those 3 items, but indeed it was moving empty, right? Because if these 3 tasks is not completed, if we don't use these join. But the thing is, our thread we have created, it cannot be reused again. Then there is another thing also, that we are creating the object and then we have to start it. The number of lines also that we have written is large, right? So okay, so let's change this distributor and okay, distributor service, let's call it distributor service runner, then using join, distributor service using join. All right, so I'm going to use latch distributor service. All right, one thing to change, it's a runner. All right, cool. So I'm going to copy paste the entire code that we have written over here. This code, I mean, you all are good with this code, right? That has been written over here.
Yeah.
Okay.
Yeah.
Cool. Okay, now I'm going to copy paste the entire code that we have written there. Cool, the same code, right? Let me run it again under the name of, okay, my bad. Okay, sneaky throws never to be written in the production environment. Be aware of that. Okay, cool. This is fine, right? Completely fine, no issues. But this thing should not be used in the current environment, right? What else we have learned till now? We have learned that, all right, what we can do is create a executor service, and executor service executor new cache thread pool. Let's take the 3 threads because we have 3 tasks. We can take another n number of threads, does not matter. And okay, not cache, right? New fixed thread pool I require. All right, so 3 services are there, right? So the thing is, I don't have, because now I don't have threads, so this thing is not making sense, right? So I can leave it also. So what I can do now, for int I equals to 0, I less than n, I plus plus, okay, n should be 3, and then I plus plus, then executor service dot submit. All right, cool. Then I have to add it in a array. All right, so I can add it in my array, no worries. So list of runnable. Okay, right now we haven't completed the list. You are all aware of list, right?
Yeah.
Okay, so I can use it, right? Like this, right? No issues with this, right? But okay,
Yeah.
so I'm using it, right? Nobody has any objection. Then pack this thing, pack cola, pack biscuit. See, I have just created a list, right? I would have created an array also, but I have created a list. So please ignore the code. If you want me to convert this into array, please let me know. Then I can convert it into array also. Anyone want to convert this into array instead of list? All right, so we are taking the list only. Cool. So this thing, don't worry regarding this. It's just a basic loop which we do with the list. All right. So I'm going to submit the task over here. So what I have done, I have simply, if anyone having any confusion, please let me know, right? So I have just created a list of the tasks that I have created over here. And then I'm looping over those tasks and submitting those tasks to the executor service. Cool. Anyone having any issue till now?
Yeah, clear.
All right, cool. So if I run this, now we have solved one thing. We have solved the thing that we should not create a thread, right? But if I run this now, what's happening? That instead of waiting for the biscuit to be packed, my driver thinks that okay, he's taking all things, chips, biscuit and cola, to the distributor while the biscuits was still being packed, right? He left that in the inventory. And if that case happens, then our company is going to lose a lot of money, because they want to sell the chips, but the chips is in the factory, they won't reach to the distributor. Then again the company has to bear the expense of the travel from the factory to the distributor. Also the chips might be the products might be consumable, right? It might get stale or get expired while it again reach to the distributor, so the company can bear a loss. Okay, this thing is not used. Why? Because I haven't added it. Cool. So now if I run this, see, let me run this again now. So now the thing is chips, cola, again the same thing happened, right? Biscuit, before biscuit is packed, the truck moved with only cola and chips. So the issue is not solved, right? We just use the executor service instead of using creating the threads, but the issue still persists that we are not waiting for our chips to come. So here to save us, who will come the countdown latch. All right, then the countdown latch will have 3. I want 3 latches as in the node on the door, right? Latch. So I want 3 latches, I want 3 these things in the door, right? And outside the door, as soon as these 3 as soon as the latch is opened, now then my driver will go ahead and will take the things to the distributors, right? Whatever he has. So when I say I written over 1, that means only 1 latch. When I write over here 2, that means 2 latch. Right now how many tasks is there? 3, right? So if 3 latches down, if 3 latches open, then only my thread should get executed, right? How, we will see it later on. This thing is clear. 3 latches, I mean 3 latches equals to 3 locks, right? I'm just not using the terminology lock, because lock is a class in Java that we are going to see in today's class also. Clear till now? What is it? 3 latches we have created. Cool.
Yeah. Yeah.
Okay, so we have 3 latches in our door. So the thing is, but we need to put that door somewhere, right? So we want to put that door in front of our driver, right? So this is our driver, right? This line is a driver who leaves, right? Who leaves before biscuit is packed. So I want the latch dot await. What the latch dot await do? It's going to wait until all latches are opened, right? Think it like a driver who is waiting behind a door and he don't know how to open the latch. Let's add a lock in the latch as well, so only the person responsible can open the latches, and he's waiting behind the door. As soon as the door is opened, he will go and start his truck. So what I've seen that okay, I have created a door with the 3 locks, 3 latches, and I have written a code over here that okay, you can go ahead. As soon as the door is open, the driver will take the truck with it and he will assume that all 3 things are there, right? So if I run the code now, what should happen? See, over here I have created a door and I have put with the 3 latches, and I have put the door in front of my driver, right? We are assuming this is a driver, right? I'm not opening any latches, right? I've used any latches, I'm not opening any latches, right? I'm audible?
Okay.
Yes.
Okay.
So let me add one more line here. Now we'll wait for all tasks to get completed. Cool. Now I will run it. So what should happen now? Okay. So okay. What? How? Da 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 da. A countdown latch 3. Okay. Okay, cool. Now it's waiting, right? It's just waiting. Cool. See, it's just waiting and it's not moving ahead, right? No one is taking the chips to the distributor, right? See, only three lines is
Oh,
there. And why it's happening? Okay, one more thing that with executors is an issue, not an issue, but it's a part of it. That executors need to be shut down, right? So, all right. So the thing is, now we are waiting, right? We are not executing because I haven't closed it, opened the door, right, for our drivers to leave. So now where I should write the code, right? Now what will happen is our task is going to get more lines than it used to. So now our task will do more than just printing things up. All right, and we can make sure that it's wait different things we'll try. What's the time? Okay, cool, no worries. We can, even if, okay, we will complete all these topics today, right? Even if it takes a longer duration, because I have to leave for Bangalore in 19th, and I don't know how many days I will be able to take classes from, because I need to go to the office every day. So from 19 till 31, okay, I will leave at 20 morning, and till 31 I'll be there on first. Okay, and in the evening, cool. So the first, okay, we'll leave, checkout is on 31. So at the evening there might be a flight, right, back to home. To first February I'll be available. I'll try to take classes from Bangalore also. Right now it's not fixed, there might be a chance we'll move later on depending on the company when they will book the flights and hotels. So I want to complete the thing as soon as possible, as many things as possible, before I move to Bangalore for 2 weeks only. All right,
Okay.
coming back to this. Okay, let me check first whether recording is on. Okay, it's on. Cool. So okay, so latches, so we want to do more work, right? So so now we know that we have created a door with the three latches. So now we need to unlock three latches as well, right? As soon as my chip is packed, right? So what I can do, I can unlock, right? I can unlock a single latch. Cool. So same thing I will do with this, and I will do with this. Cool. So as soon as my task is completed, it will unlock a latch in the door. And once all these three latches are opened, my door will be unlocked. Where have you used the latch? Okay, my door will be unlocked and the driver will leave, right, with the biscuits. Cool. Visible?
yeah, yeah.
All right, so let's run the code and see what happens now. See, we were waiting. This is the main thread, right? This is the main thread. This is the this is the truck driver, right? The main thread. So the chips was packed when the driver was waiting for chips and cola to get packed, right? And when cola and chips was packed, the driver will take it to the distributors, right? What we can do, because this happened way too quick, what we can do is we can make sure that our thread is sleeping, right? And this is the thing that I hate with this. I have to use try and catch. All right, so I have written for cola to get packed, I have written 3 seconds delay, right? So now let's run this again just to make sure. See, waiting for the cola for 3 seconds. Okay, let me make it 10-second wait. All right, so see, now if I run this, okay, cola, okay, my bad. I have to print it later on, right? I have to put it down. Okay, all right, now let's run it again. Now see, the thing is, cola will going to take 10 seconds, right? Driver was already there to pick up the chips and all things, but the thing is, chips and biscuits are packed, but cola is not packed. As soon as cola is packed, driver will take those things and leave, right? Visible?
Okay, okay. Yeah.
So now the thing is, if we are going to use the thread join is not used in today's era in 2025. It's not even being used from 2009. But in 2022, no one should use, right? Even still, I have seen people who ask question, right? Thread.join. Completely chill, no worries. I have respect for people who ask the countdown and latch, because these are the things that we use in the today's era. Why? Because if you try to use the join, you need to create a thread. And again, if you want to create a thread, there are chances where we want to get a thread and want to make sure that the task has been done in a single time only, right? We don't want our task to get executed by some thread that is in the pool. There might be a thread management or the memory management issue that might occur with that particular task. So there are chances where we don't want our task to get executed by a thread which is in a pool. Or because there might be a chance also that our thread pool is of limited number, right? For example, in this case, okay, in this case we have used only 3 thread pools, right? Okay, we have only 3 thread in the pool, and for example, let's say that there are 3 lakhs requests, right? So for those 3 lakh requests, I have a limited set of only 3 thread pools, right? So 3 lakh task is going to take a lot of time, and if my task is urgent and needs to be executed upfront, I should not put it in a case my where my thread pool is working, right? Because in a case where there is high load and a high number of tasks, or example DDoS or DOS attack, no one does the DOS attack now, DDoS attack, if some this kind of thing happens, so my tasks in my executors, the task should not get way too much, so that my task completion timing becomes way too large, right? So that should not be the case with a task that needs to be executed on priority. So in that particular case, some people argue that okay, thread equals to new thread is required, right? Because we can start directly a thread and execute, right? It's making sense, right? Hello, I'm audible. Okay, let me break
Yeah.
it down. If I'm using executor service and wants to submit my task, then I'm just submitting it, right? Depending on the bandwidth of the task presented in the executor service, and I mean, when I'm saying the executor bandwidth, that means that how many thread it has and how many time and how many tasks it has to execute, right? Because there might be a chance that I want to execute something urgently, and in the executor service there is 3 lakh tasks already been submitted, right? So I don't know when my task is going to be executed. Is it making sense?
Okay, okay.
But I mean, Dikshita, is it clear?
Yeah, yeah.
Okay, so the thing is, okay, it's not all right. Let me see. This is all the design things, right, that we are talking about right now. This is not something that usually is involved in Java, but everyone should know it. Somewhere down the road, you will read about optimistic logs, pessimistic logs, this fork and join, those or everything. You will find it somewhere, right? If you will read optimistic log in Java, completely fine. If not, then you will find it somewhere in the database. In the database also you can find, and in the database also there is Hibernate that we use. It's an part of ORM. So over there might be a chance you will read about pessimistic or optimistic log. If not there, then in the operating system there might be a chance that you will read about it, right? So somewhere down the road there are some concept that works in the entire computer science area. So you have to know it somewhere down the road, right? Regardless where you use, like the example of this pool, we are aware of the pool concept, right? Pool is a design pattern. So over here is a thread pool. In the database it becomes connection pool. Database, we need a connection pool with the database. So similarly it just keep on evolving, and if we are using in some place, then it will become that pool. So pooling is a design pattern. So somewhere down the road we need to know it, so that's why we are covering it here. So at least you have in your back end of your mind that okay, this is how we use the things. So let's, again, this is a interview question, right? Some people might ask you this. Okay, so the thing is, if I have task number 1 2 3 4 5 6, all right, and 7 and 8 and 9 and 10, let's suppose this is the submitted task, right? And this is my list of task, right? This is my list of tasks, and each task, let's suppose one task one task can take uh, 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 let's say 20 seconds, 10 seconds, right? So if my important task comes, then it's in the 11th number, right? So it's going to take 11 seconds if I have only one thread, and there is no way to find out how many threads I have in the thread pool. I mean, obviously I can read the code, but the number of threads I don't know. And if I'm just submitting it, then I don't know how at that particular moment how many threads will be there, right? And at which number I will get my thread, my task will be executed. So it's better if I want it to urgently get executed. So what I can do, thread, my new thread, and I task, important task, and start, right? Now I know that it will be directly submitted to the thread scheduler, right? For asking to provide the CPU, right? Am I audible?
Yes.
Yeah.
So this way seems to be better approach if a task is urgent, right? Instead of submitting it to the executive service. But the thing is, for that also we don't require this. We can use completable future. Now completable future has come in the Java 8. So if you provide the answer of this, new thread is required in 2010 or 11 or 12. If you would have answered this, then it's acceptable, but not in 2025. I mean after 2023, because completable future is also for the same thing. A little bit different because it's a okay. What's a daemon thread and what's a non-daemon thread?
The threads that run in the background, they are called daemon threads.
Main thread is a daemon thread or a non-daemon thread?
Main thread is non-daemon thread.
Okay, the main thread get name is the daemon thread, right? This thing we have done. Let's run the code again. Thread main is a daemon thread false, right? Whatever the okay. I don't have to run it again. So see, over here we have written also background thread, right? So daemon thread is a background thread, right? So the thing, okay. So why these things are important? Because I was about to. Okay, so everyone is clear till now. I mean, we have covered this, right? What's a background thread and what's a
Yeah.
non-daemon thread? The JVM will not stop. Like in the game of a Mario, the main thread will be, non-daemon thread will be the player, right? And the background threads will be the cloud and the turtles, the owls that keeps on moving here and there. So if my main player is dead, I should not wait because my turtle in the game is moving or my cloud in the game is moving. I should not wait for those things, right, to get completed. I should end the game quickly. That's the thing that happens in today's era also. So there are some background threads and some main threads. Okay, so again, main thread is not called because there are everything is main in the Java with the main keyword. So the thing is, background threads, we don't wait for the background threads, right? If the non-daemon threads are completed, then we don't wait for the daemon threads. That is the background threads. So the drawback with we'll cover this thing is today also. The completable future is a daemon thread. It's a background thread. So it's going to get killed as soon as my non-daemon threads is not there anymore. Cool. So that's the drawback of this thing, but there is a conjunction that we can use it with the executor service, because executor service we have to shut down eventually, right? So this will make sure that our task is completed and it's not our JVM is not shut down till all our threads is completely executed. So in today's era, if someone asks this, then the answer is we can use the completable future in that case if you want to execute something urgently on the urgent basis and don't need any executor service to be in front with having a thread pool, right? So that's the thing. Even the completable future use the fork join thread pool, but okay, we'll talk about this later. This thing is clear, right? Why the latches are better?
Yeah.
Okay, all right. So now the thing is, we have covered the latch. Latch is an advanced version of the join, right? We don't use join in today's era. It's better to use the latch. And with latch, the thing is, see, okay, I think we have missed the point. Okay, so we have to work with the three thread, right? In this, okay, in the earlier example, we have to work with the three threads, right? We have worked with the three threads. Uh, 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 uh. Okay. So these three threads objects were there, right? And I have to keep on writing the join, right?
Yeah.
But in this, why I have written it like this, I can even change a little code over here as well. As soon as you, okay. See the task, okay. You can have the size of this thing, right? If you already know we are writing the task already also over here, but in the real life scenario you will get the list of tasks, right? So what you can do, we can directly write code okay, like this. Instead of writing in this manner, we can take the task dot size. All right, so if you add another task in the list, so you don't need to change this thing, right? You just change the code here and you write the list dot count down here, and that's it. You don't need to do anything more, right? Entire code you no need to change. Just write your runnable and write your task and add your task in the list, and everything will be taken care of itself, right? Am I audible?
Yeah, yeah.
Okay.
Yeah, yeah.
That's not the case with our threads, because you have to write the thread. And if there is some another method where you need to send these things, right, to write the join. So let's suppose there are 100 threads, right? So you need to pass 100 threads and then you need to write 100 join on that method, right? And it does not make sense to pass that number of threads to put the join again and again and again, right? Because these things needs to be done upfront. The join you need to write it the upfront. But with the lock, because you are writing the putting the lock over here, right, when these lines are being executed. But in the latch you are putting the locks first and then removing it. Over here you are putting the lock and then removing it, putting the lock, then removing it, putting the lock, then removing it. So that's the case with these two. So latches are way too easy to handle when we are working with a large number of threads. All right, let's move to the barrier now. So again, this again barriers again also good example. So let's directly take the example for this one also. Okay. Okay, cool. Let's go ahead. Let's write example barrier. And okay. Cool. Okay, I got the example. In the game, there is a game we need to organize, and the game is of running. Cool. Running as in the 100 meters Olympic race we want to create, right? So each thread will be a player. Cool. Let's write a racing event runner. Cool. So what's the requirement for this? We want to replicate an Olympic race event where all players should wait at starting point and start running as soon as okay they fire a gun, right? Gun is fired. Cool. So okay, so let's say I need to create threads, right? Runnable and player 1, and now player will run, right? Directly it will run. So okay, my bad. So let's write over here sys out, and whatever thread is running this current thread get name plus is running, and player 2 and player 3. Okay, cool, great. So I have 3 players for now, right? And in my executor service I can use, so executors thread pool, let's take 3 threads and executor service, and then what I'm going to do again, int equals to 0. Okay, even just directly submit, I can submit it directly, no worries. It's submit player 1 executor service, submit player 2 and executor service, submit player 3, right? So now the thing is, and sys out race is completed. Cool. Okay, then wait is okay. Instead of this Okay, okay, I should okay, Ray should start. Ray should start. Cool. If I run this, what will happen now? Before race is started, okay, race started, should start being race started. Before I'll say race is started, what's happening? Okay, it worked fine this time. Cool, no worries. Let's run it again. Okay, again it works fine. Let's run it. Okay, let me shut down it as well. Execute service dot shut down. Okay, let's run it again. Okay, why it's working properly every time? Okay, it happened. Okay, multiple times. Should I increase the player? Okay, this time, right? See, race started later on. My two players already started running, right?
Yeah, yeah.
So this is wrong, right? What should happen is my thread should wait, right? My thread should wait until I have started the I have fired the shot in the air, right? Then all players should wait till then, right?
Okay.
So now the thing is, so how I will make sure that this thing will happen. This thing should happen. Hello, I'm audible. Okay, so we don't know anything, right? So the answer is already written here, the barrier. So I will put the barrier in front of the players, and so the barrier that I'm going to use here is it would be the cyclic barrier. Alright, barrier, new cyclic barrier. Now the thing is, cyclic barrier can have how many players you want to reach at the starting point. What's happening right now, that each player, when should I fire the shot, right? As soon as all the player reaches to the starting point, right?
Yeah.
So I have three players, so I have used three unit for my barrier, right? So what I need, okay, again my task will not do a single thing. Now my task needs to do more things. Okay, okay. So all right, player 2, player 3. So I can just remove this player 1 and write first for this. And okay, my bad, it's not in the sys out. Okay, and then here I need to do more tasks than just to print the stuff. And I don't want my player to be running up front, right? So my barrier is there, and my barrier should be there until 3 people should come. So what I'm going to do, barrier dot await. Okay, oh shit, I'm inside the this lambdas, and lambdas, the thing that I hate is I need to use the try and catch. So there is a barrier dot away. Oh shit, I have to write it again for everything. So 3 players is there, so why should I write it 3 times? It can work in a single time. Okay, get running task. Okay, I'm going to make this into a method. Okay, get running task. All right, so what's a running task? Running task is nothing, just a normal method where I'm okay. I will print it later on. First I will try to wait for my barrier, right? Barrier to get broken. So as soon as my thread comes, it will wait at the barrier, right? When the barrier will be broken, we will see later on. The barrier will be broken when 3 threads will be waiting, right? When the 3 threads will call this method. But does it say? It say if the thread class is the last thread to arrive, and non-barrier action. Okay, so we'll see it later on what it's saying. Okay, wait until all parties have invoked await on this barrier. So visible what it's saying, it will wait until all parties has invoked the method. That means how many parties required, we have mentioned that 3 parties has been required, right? Over here it's parties, right? Cyclic barrier int parties, right? Visible.
Yeah.
So, and we will see later on here barrier action is also there. We'll see what is it in later on. So 3 parties is there, right? So, and it will wait. But the wait is saying, that it will wait until all parties is 3 that you have mentioned, have invoked await on this barrier. So it will just wait until all parties will call the method await. And how many parties is there? 3. So as soon as 3 players will call the await, it will move ahead. All right. I'm audible?
Yeah.
Is it clear? Hello, is it clear?
Yeah. Yeah.
All right. So the thing is, if I'll write this thing here, so it will not make any sense. So as soon as my barrier is broken, I want to make sure that something, right? A fire should be shot only if my barrier is broken, right? And when the barrier will be broken, when all parties will be at the starting point, right? When the all parties is waiting. What does it mean by the starting point? The parties I have mentioned 3. So if all parties has been in the starting point, and how we'll know that a party is in the starting point? We'll know if they are waiting at the starting point, right? Someone comes and asks the coordinator, okay, I have arrived. Player number 1, I have arrived. If he's telling to the coordinator that I am arrived, then second person will come, okay, I have arrived. Then the third person came and he will also say, okay, hi, I am arrived. So as soon as 3 people arrive, so the coordinator knows as soon as 3 people arrive, I need to fire the shot and they will start running. So now the thing is, I can run it over here. The thing with the earlier code that we have written, if we run it, right, we won't be able to know. Okay, right now they have worked in the previous synchronous way, but earlier also, if I try to run it multiple times, one time, okay, see, multiple times if I run, it should provide wrong answer somewhere down the road. Okay, the threads are less, so it's not giving a wrong answer earlier. Okay, so what I can do to make sure, okay, wait, if I'm submitting the task, I'm putting loop inside it. If I increase the number of tasks, then system started and it's all started running after it. So my this thing is being printed first and then they are starting running. All right, cool. Let's say that there is a task over here. Okay, but it does not make sense. This is something else. They can run first and then, okay, the barrier is broken later on. All right, cool. So if I put it before and run it, okay, then it won't make sense. It will, okay, how I can make sure that it player started running? It's taking some time. So what I can do, if there are multiple threads, that's why it's taking a little bit time. So what I can do, I can put the thread dot sleep 2000. All right, and sneaky throws over here. So I'm deliberately writing the thread dot sleep because I'm unable to find. I mean, I have to, otherwise I have to create a lot of threads and create a different thing. So now the race has started and before that players has run, right? So how would I know that players are running in the same manner? The race should start as soon as the barrier is broken. So what I can do, simply, the barrier has a overloaded feature that it take a task also. As soon as your barrier is broken, you can put a, okay. So let me write in this manner, runnable or start race or start a race task. All right, This thing is clear, right? I have created a task, start race task. Clear? I'm audible?
Yeah.
So I'm putting it here. Cool. In the barrier, I have mentioned that, okay, please wait for 3 parties, and as soon as 3 parties has arrived, please execute this task first. And as soon as you execute this task, then let the players move ahead, right? So if I run this, so race will start regardless of the, if I put sleep here and there is no issue with this. Now if I run the code now, the race will start after all the threads come, right? And I can even make sure that one thread makes a delay also. Okay, but I'm using just simple tasks every time, so okay. So I can over here try and catch is already there, broken barrier interrupted is already there, so I can write thread dot sleep and 2 second sleep I can put here directly, right? So now okay, I have to put before the barrier. Okay, cool. So now I have run this. Now I'm waiting, we are waiting for the players to come. So let's add one more line. This out, waiting for the players to reach the starting point. Cool. Now we can see waiting for the players to reach the starting point. So as soon as all the player reach, we started running, right? So race, and this person has started, right? Visible? Hello, I'm audible?
Yes.
Okay, example is clear, right? Anyone having any doubt?
Yeah.
We can change it also, right? If we want to make sure that different players are waiting, giving different times. So what we can do is, okay, then we need to add another sets out also. We are not doing it because we want to add other thing also. You can, but if you want to play with it, what you can do, you can create 3 separate tasks and have different times, right? And also print which player has come. Player A has waiting, player 2 has come and waiting, player 3 has come and waiting. Okay, let me do it. Okay, so this out thread dot current thread dot get name, and then player has come and waiting at, and over here we can put the timing also, system dot current milliseconds. Cool. So we can, and let's divide it by 1000 also. All right, so this simple thing, what we can do, we can replicate it twice and get running task later. And over here player has come, and this make sure that we are waiting for 10 seconds for this player. And for a normal task, what we can do, okay, for a single task, get for player 2, what we can do, we can take the later task. Cool. Now if I run this code now, see, waiting for players to come, and player 1, 2 and 3, everyone come. Okay, wait. So okay, let me, we have to write below it. All right, so we need to write the code below it, so that's how it's going to make sense. And let me write a little more time, and let's write 3 methods for 3 different players. One will wait us for 10 seconds, and one should make sure that we are waiting for 20 seconds. Get 20 seconds. And 20-second delay task. And let's convert it into get 10-second delay task. Alright, going back to this, get 10-second delay task and get 20-second delay task. So now if I run, what will happen? Okay, we are waiting for 2 seconds. See, player 1 has come, right? At this time. Then after 10 seconds, player 2 will come. We are waiting for the player 2. Player 2 has come, right? Now at this time. Then after 20 seconds, player 3 will come. And as soon as the player 3 will come, the race will begin. See, the player 3 has come and restarted, right? Everyone started running. Cool.
Okay, got it.
All right, so let's move to the next topic. See, this is the only topic, the multi-threading, that I enjoy teaching. Otherwise, every topic is a little bit of the streams. Otherwise, every topic is very basic now. You can see the thing is, these type of examples, if we create, then we feel happy because it's a real life example. All right, just give me 1 second. I just got a message. Okay, cool. All right, so okay, so barrier is closed. And all right, okay, so the use cases of latch and barrier we have seen with the live examples, and we have taken two different. One is factory delivery system and second one was racing event, right? Okay, and now completable futures. Cool. Okay, but for the completable futures we need to know the supplier also. All right, so the first thing that we get when people ask about, okay, let me show you the suppliers first. Okay, let me show you the completable future example first, then we'll talk about these things. Package basics, and okay, see, then interview question, let's write only two interview questions. Okay, in basics we'll write a runner. So completable future runner. So see how we were executing a task till now. We were writing a task, right? Runnable task equals to, let's suppose we are writing hello Dikshita. All right, spelling is wrong, right? Dikshita, Shita. Okay, I don't know, is it correct?
Yeah, there's no H after the key.
Okay, cool. So this is the task to say hello Dikshita. Okay, we could have used hello user, but cool, no worries. So what we were doing earlier, the one thing that we have used is thread, new thread, and then we submitted the task, and then we started a task, right? If we run this, okay, no, my bad. Okay, I don't want it. Run it, hello Dikshita, right? This was the one of the ways in which we used to write the task. Another way was to create the executor service, right? So executors dot current thread pool, I'm saying okay, give me one, and I want to submit a task. Cool. So this is the another way that we have seen, right? Okay, I have, okay, so this thing provides the executor service. I am directly putting the value, right? So that's how executor service we have used. Now the thing is, there are another way. It's called completable future, and then run async, and I can just put the task. So now the thing is hello Dikshita, hello Dikshita, hello Dikshita, right? These are the three ways in which we can write the thread. Our task we can execute our task in different thread, right? So if I can add one more thing over here, the difference that you will see, thread dot current thread dot get name, right? Everyone will provide their name, right? So you'll see the difference now. Thread 0, okay, my bad, let me add this thing, right? Now it will be better to see. So now you will see thread 0 for the thread, right? Pool 1 thread 1, because it's used pool, right? Because in this is been executed by the thread executor, so it used the pool. So I have why thread 1 only, because it has only one task and one, I have created only one thread as well. Now over here you will see the fork join pool, right? And it calls worker. In the completable future, the threads has been called by the worker. It has a fork and join, and what it used, why it used, not going to cover in this course. You can read it on your own if you want. There are multiple pooling concept, and there are multiple things in which, I mean, we divide the task in simple way. We divide the task and then we join, we fork the task into different single entities, and then we combine the result. It's called the fork and join. All right, cool, not going to cover it later on. So the thing is, in three ways we have covered, right? So far we have seen the three ways, right, to write it. Which is the best if you want to execute a task in a single time only? Hello?
Yeah, yeah, yeah. Means the first one, I guess.
Why? Okay, all right. What's the okay? You're not aware of this thing right now, right? Completely cool. So why first one? Okay, cool. Your answer is correct, but why? This is also good, right? Because only my thread is not going to wait. Because executor service is not taking any more tasks, right? Because I haven't created any executor service object, right? I have directly created a thread pool and then submitted a task. Every each of these tasks will be executed as soon as the request is submitted. So it's not about the delaying. If you have some other reasons to to feel better, the executor, oh sorry, to feel the way that thread creation and then submitting it, it's better than the executor service, then you can add those things. One of the drawback is the code is still running, right? Now how can I stop this, right? I have to shut it down also, right? Executor service needs to be shut down, right? If I
Yeah,
write it in this way, I cannot shut it down. Another thing is, if I have a task that needs to run at a single time, why should I create a thread pool for it? It don't make sense to create a thread pool, right? Thread pool is being created to make sure that I can reuse that thread again and again. If I don't want the thread, this entire executor service is not going to be used again, right? Let alone the thread. If I don't
yeah,
even have that executor service object, I cannot submit any other task. If I cannot submit any other task, then it's equivalent, it's worse than this, right? Then
yeah,
out of these two, this one wins, right? If I have to execute a single task, because I'm not creating any stuffs that multiple objects I'm not creating, right? And internally it's already creating a thread, right? So it's better, and it's keeping that thread into a thread pool. Then it's creating the queues, right? We haven't covered that thing. You can read it on your own. The priority queue and blocking queue, there are different type of queue that it creates internally. Then there are multiple objects that has been created, right? Because executors are entire framework. It's not just a single object that we are creating. So we are using an entire framework just to run a single task. So it's better to run the this thing only, right, directly. But again, thread objects creation, then manipulation, then all those things again is not good. So, and the thing is, with new thread, you can never get a value return from it, right?
acha, oh,
I mean, the second part is way too less important. But with a completable future, you can just directly put it. What's the drawback of this? This is a run async, returns a new completable future. I can see, okay, fork and join pool after given action. Okay, cool. It's not mentioned that it's a daemon thread. But, but, let's just, okay, 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 let's just add one more detail that, okay, hello Dikshita, is it a, my bad, is daemon thread, then plus, and then plus, and okay, and over here thread dot current thread dot is daemon. All right, let's run it now. See, okay, why only two threads? What happened? Okay, my bad. Let me add the new thread. Okay, new thread task, and then start. Cool. Let me run three threads now. So now you can see the thread 0, which has been run by the normal thread, is not a daemon thread. Okay, let me just add one more thing. Colon. Cool. Let's run it again. So this thread 0, we know that thread 0 has been provided by the thread, right? Thread object. So it's not a daemon thread. Pool 1 thread 1, we know it has been provided by the executor service. This naming. It's also daemon thread? No. But what about the fork and join? And fork and join has been provided by the completable future, right? How can we be sure? Over here you can see the fork and join pool, right? and if you go here you can find, okay, so pool. So all right, let's not go into this. So you will find inside here, if you find, you will find that pool, it's used as the normal pool. So over here you can see it's a daemon thread, right? So it's not going to wait. So how can I make sure that my daemon thread should wait? We can provide the daemon thread into the executors. We will see it in the later on. All right. So these are the, okay, so this should be okay. Let's change the name of this, and always, all possible ways to run a task. Okay, different ways to run a task, different ways to run a task. Runner, cool. Okay, it's not a valid, okay, space I have provided to run a task. All right, so I changed the name of the class. Cool. Clear till now? Anyone, any doubts? I have directly provided the task to my completable future, right? And it will run, and it provides an object of completable future and void, right? Because Runnable provides no return value, right?
Okay.
Now another thing is Supplier, and we already seen Runnable. Again we have already seen Callable. Runnable we have seen, right, used multiple times. It's an interface, functional interface. It's used to create the task, right? Callable, again we have seen, it's a, okay, my bad, cannot use it directly. So callable also a function interface we have used by creating a thread. It's also used to create a task. But if you want to return something, right, we have used in the last part. If you want to return an integer, put integer over here. If you want to return void, put void. If you want to return custom object, put custom object void. That's it. Now what the hell is a supplier now, right? So as the the thing that I have mentioned earlier, that if in a major version change, whenever a new version comes with a major change, right, they tend to provide a solution to the bigger problems that the language or any software has. So there were some problems, still there were some problems with the multi-threading, and there were other problems as well that they have solved in the 8, like null pointer exception. They have provided this optional for null pointers. Then there is streams, right? Java was not a functional language, and the functional language was important to make sure that it works better with the multi-threading, because they increases the encapsulation. So if there is high encapsulation, I mean the highest level of encapsulation you will find only in the functional language, right? Because we don't have any reference to the object. So whenever you make change to a data, you pass that process data to the next function, and before those two function calling, no one has any reference to that particular data that you are keep on processing. That's what's happened in the when we use the streams also. So no one has the, whenever you are modifying your data using the streams, no one has the access to that modified data to come in between and use it. Add it with the security that the Java provides in non-pointerless way of Java, you will have complete security along with the completely full encapsulation that works wonders with the multi-threading environment. That's why the functional programming is also at the top, because there is a issue, right? The issue that we have, that multiple threads will, if multiple threads will try to access the same resource, the data is always wrong, right? I mean, not always, but there might be a chance the data is wrong. And whenever we work with a firm which has the high level of daily active users or DAUs, over there your test case of whether the data is coming wrong or right will always be wrong, because anomaly will happen if multiple people are using your resource, same resource multiple times. So to counter that thing, if we convert into a language which is functional and where the data is fully encapsulated, then no other thread can access that data while it's not completely processed. So no one will able to modify it in between. So that's the case with the functional language. If you don't understand it, no worry, we will, okay, we are not going to talk about the functional languages, but in a stream we will see it. how it works, right, and why it works, all those things. Streams is also a good thing. If you don't know the function, if you are from the background of the, if you're from front end background and you know the javascript is a function language, then it becomes way too easy for you, because the first level function, second level functions, all those things are also now in Java after 2013 with the Java version 8. So 8 version provides us the lambda, the completable features, the supplier. Earlier there was runnable, then comes callable in 1.5. See, callable comes in 1.5. See, visible? 1.5 comes in 2009. And see, it also saying that C executor also, if you are seeing the callable, because how will you be able to use the callable if you don't know the executor, right? And there is no other way to execute. I mean, in 2009 there was no other way to use a callable without knowing the executor, right? So that's why C also executor is there. So similarly, if we go and see the supplier, if we go and see the supplier, then we will see here it was introduced in 1.8, right? And over here, they are not mentioning to read about the completable future, but completely fine, no worries. So what's the difference between the supplier and the callable and the runnable? See, again, very less companies is going to ask you this thing, because people rarely know about this, so they are not going to ask this. But who knows, can ask. But it's a non-rejection questions, right? Still, you are just leveling up as a developer, especially in the Java language. But it's not a rejection question. If you haven't used supplier, then it's completely fine, no issues, right? You can say that I've been using the other things, callable, runnable. I haven't used supplier in my entire life. Completely cool, completely acceptable, no issues. Cool. I'm audible? But if you have
Yeah.
mentioned that you have used multiple threading, same thing I'm going to repeat. If you have mentioned that you have used multi-threading extensively, and you have mentioned that I have used the completable future, and if you have mentioned that you have used extensively multi-threading and used completable future, then you don't know the supplier, then there is an issue. Don't write it if you don't know it. That's all. All right. So coming back to the supplier. So what was the issue with runnable? Sorry, callable. Because runnable. What's the issue with the runnable? Hello.
It doesn't return anything.
Okay, that's the only issue with the runnable, or there is some other thing also? Okay, so let's go inside the runnable and check what's the difference between a runnable, public, abstract, void, and run, right? So you have mentioned you have only seen the void, right? And it's an interface. Callable will also be an interface, so callable will also have these two things, right? So it's only have void and run. You have also mentioned that void is there, and in callable we return the value, whatever value you mentioned. So there will be a difference. You will see over here. It's not throwing any exception, right? I'm audible? Hello?
Yeah,
Yes.
correct.
It's not throwing any exception, right? So the thing is, the thing that I was saying multiple times, that we need to, let's go to the latch and barrier example. Race event. We have to write multiple times. We have to write multiple times try and catch, right? In every example, we have to write multiple times. The reason is I cannot throw exception, right? With the callables. Am I right? If we completely change this thing, instead of runnable, if I do make it callable, and let's say callable of void, I just want to use callable. If I'm returning nothing, then it's just I'm using callable, right? It's exactly same as a runnable. I want to return nothing. Cool. So, and if I'm doing this, and if I'll try to remove this, and what else is left? Okay, return. Cool. Visible. Okay, return, missing return value. Okay, my bad. So return, it's I'm returning here, return nothing. I have to return nothing. Okay, let's make it integer. I don't have to do anything, and then I can put return 2. Cool. So now the thing is, now what is this? Okay, it's already defined in, okay. So running task, callable task, cool. Now the thing is, I don't need to write in the thread itself, in the task itself, I don't need to catch, right, anything. I am able to throw exceptions, right? Because it can throw exception. I don't even need to mention throws exception, cause the method itself throws exception of callable. Visual layer.
Okay.
So that's another thing, and that's the, I mean, returning value, it's good, but instead of this, if I want to ignore handling the try and catch, I can directly go with this thing, right? Let's remove this one now. And coming back to callable, so there were two things, right? One is this, it don't throw the exception, and it throws an exception, right? They are not forcing me now to write a thread with code in which I need to handle the exception if arised in the same thread itself. Okay. Am I
Okay.
audible? Cool. So you understand these two things, right? So now what's the issue with the callable that we need to rectify later on with the supplier? See, now let's move to supplier. Public abstract will always be there with everything, right? Now if we go to the supplier also returns the value, right? But it don't throw exception. So that means if you're using the supplier, you need to have exception handling inside your task itself. In the callable, you don't need to handle the exception inside the task, but you in supplier you can return a value, but also you need to handle the exception inside the task itself. So why it was important? Even though it is good for the callable, it has provided us some space whether you want to return, I mean, handle the exception or not. But in most of the cases, what usually happen, because there was executor service, if I have provided, if in the executor service I am going to put 1,000 tasks, right? And out of those 1,000 tasks, let's suppose two tasks, I mean, there is an error with two tasks, right? So what will happen with the thread that's executing? Let's suppose there were three threads, and let's suppose a thread, okay, let's suppose only one thread is there, and there are 10 tasks, and task number 3 will throw an exception. And who's going to handle that exception? What will happen? Will my thread be dead, or will my thread move to the next task? If will it go to the thread 4? Will it not go to the thread 4? If it go to the thread 4 and it will not stop the execution, if the thread will not die, the task will just keep not completed and thread will not die. So how it will be logged? Will it be logged or not? Whether will I get the information that okay, my task has incomplete, or has some error? So how it's going to get conveyed? So there were a lot of issues with that, right? These are the questions, right? One might ask. Hello.
Okay. Okay.
Right, so to cover this thing, so we wanted a better way in which even if I wanted to provide in a thread pool a task, right? So I want to make sure that my, okay, let me write the code first for you, right? I don't know whether, okay, 11 is there, and we haven't even started with the locks. We haven't even covered the completable feature. Okay, all right, no worries. Okay, different ways, why? Okay, I have to remove this thing. So what I'm saying, in the executor service, it will be better understandable. Where is okay, multi-threading, executor service, executors, basics, and the question task one. Okay, task throw error runner. All right, so psvm, so let's create the tasks. So okay, first the thing is executors, new thread pool, and then let's suppose a single thread is there, right? Now executor service and a task. Okay, runnable task equals to, we were doing this right till now, sys out. Okay, creating task, cool. And then I can simply submit it, submit and then task, cool. Now if I run it, okay, I need to close the also. So executor service dot shut down, not just shut down, so keep it below. If I run it, okay, my bad, it's running something else. Creating task, right? Execute it. And now if I want a callable to return some value, callable, let's suppose integer callable, and return 1. But what will I do with the value 1? Okay, task fetch value, but if I submit, I want to print also something. So and to create, I should print sys out callable task, and I can submit it callable task. All right, so my executor service submit callable task, right? Visible. And I can again submit. Okay, so okay, I can again submit my task. So what will happen now? 2 times greeting and in between callable task, right? This is what we wanted. But what if I'll just randomly say, let's do some fun and let's do this thing. What will happen over here?
Exception.
Right, arithmetic exception, right? So now if I run it, what should happen? Should it run the next task? Should it close the executor service? Should it stop this? Whether it will log the error or not? What should happen? If I run this thing, what happened? Where is the error? Where is the error? Error should have been happened, right? If I write this thing in the try and catch sys out exception arised and then print d dot gets message. If I run this now, we get the exception, right? That means exception has arisen, right? But it was not logged, right? It was not logged, right? Over here it was not visible in our console. Visible?
Yeah.
So the thing is, you will not even know that something had happened with your task. So what eventually you end up doing is you will send error email, and then you will mention the stakeholders and then the data and then all those things. So, and then there is an issue with this also. If our system get closed before sending the email, if somehow due to the downscaling or the upscaling something has happened, then also you need to take care of something that, okay, shutdown hooks, shutdown hooks is also not covered till now. Give me 1 second, let me write it down. Again, shutdown hooks is also a good question. It's a part of interview question as well. This we also will cover tomorrow. Shutdown hooks. All right. Okay, so Java, I mean, multi-threading is extensive, little bit extensive if you want to cover everything. All right, but shutdown hooks is important. So what happens with the shutdown hooks is the same thing, right? I want to send mail, but if our system wants to downscale, then I want to make sure before the JVM closes, shutdown, I want to complete some tasks that I can put it into shutdown hooks. So before closing the JVM, a certain task will be completed. So I can make sure that When I'm sending the email, it has been sent to a queue, and before shutting down the JVM, those queues should be empty. Then only we should allow the JVM to get shut down. If we are nicely shutting down the system, otherwise it won't going to follow. Clear?
Okay.
So okay, so this was the thing. This was the issue with it, right? So you can have it. So automatic exception not to be logged or displayed in the terminal or log for the logging, right? Cool. Clear till now? So that was the issue with this. Why with the callable, right? It's a good thing that you are not forcing us to handle the multi-threading. I mean to handle the exception handling. But the issue with this is you're not even logging it properly, right? You're not closing the executor service. You're saying, okay, I was the threads one or the thread zero was trying to execute a task. He's unable to complete the task because there was some exception. I don't care. I'm moving with another task that I have in my queue. So that's the thing with the executor service. But with
Okay.
supplier, it has changed it. Because supplier now, if we see the supplier, so the supplier also has the value to return, but it don't throw exception. So you need to handle the exception inside your
Supplier.
task itself. So you have forced your task to write the send error and all those things, right? You have been forced to handle those things, those errors. So that's the upgradement that has been provided with the supplier. So usually, I mean, you will be asked rarely, but you should know when you use something, right? So that's the difference, and that makes you different from the beginner or the normal people, right? All right, cool. So now we know about the difference, right? Supplier. When to use supplier? Okay, this is the question that I'm asking. Different runnable versus callable versus supplier. Dikshita? Okay. Are you in this class? Okay. Dikshita, you want to answer? You are there in the session?
Yeah, yeah.
Okay. Supplier versus callable versus runnable. When to use which one? All right, cool. No worries. See, if I don't want to return anything, then I should use runnable. When I want to return something, but I know that I don't want to handle the exception handling, then I should go with the callable. And when I know that I want to return something, but I want to make sure that exception handling should be handled in the task itself, then I will go with the supplier. And again, why you need it as a fresher, it's completely fine if you don't know it. If you are tech lead, then you are responsible for designing. If I'm writing some executor, I'm writing some service that is wrapped around the executor service, that you can just send your task in my class, and in my static method just send a task and it will be processed, right? If I'm writing this thing, then I will make sure that they are sending the runnable or the supplier. The reason being, if they are sending the callable, then the exception handling will not be done, right? And because my method will be, the task will be sent by people, I mean, the task will be sent by another people, right? If I am aware of these things, so there won't be an issue if I'm writing the code. But if someone else writing the code and they are freshers and they don't know it, and most probably the fresher won't know this much, so they will try to pass the callable along with it, right? They will google something, and with the partial knowledge they will try to pass the callable, and with the callable then there will be an issue, right? Even if we try to find something in the logs, then nothing will be there, right? And we will be just wondering what happened. So for if you are a tech lead or at that position, then these things you need mandatory, you should have those skills. So that's why it become hard to crack into good companies as a tech lead. That's why a lot of people entered in the fresher or SD1 SD2 max to SD3 level, right? Very rarely people move from tech lead to tech lead positions. So that's the reason these things they require for you to know. Clear?
Yeah, yeah. Got you.
Okay.
Now tell me, Dikshita. when to use runnable, callable, and supplier.
Yeah, so runnable, we could use it when we don't want to return anything.
Cool.
Uh,
And want
and
to handle the exception also inside the task.
okay, okay.
Yes, and then
And callable is used when I mean callable has the exception handling, but it's not necessary to use it. So that is the advantage of callable.
and it returns the
Uh,
value also.
yeah, yeah,
Okay.
yeah. And supplier is when we handle the exception as well.
And want to return the value as well.
Okay,
Okay, two things we play with, right? Whether
yeah,
it's
values.
returning something or whether it's handling the exception. Two
Yeah.
things: whether you are forced to handle the exception or it's return you want to return something. So runnable force you to exception handle and don't allow you to return anything. Callables allow you to return value, but it's partial. If you want to handle exception, then cool. Otherwise, not mandatory, right? And if not mandatory, pressure is not going to write it, as plain as that. And then supplier takes over the callable.
We have to.
Yes, and you are forced. You will get the value, whatever you wanted with the supplier, but you have to handle the exception in the task itself, right? So supplier is a great save, but you have to know it's a great save if you know it. Cool. So important thing, difference between these three. Great. So okay, let's now we can see the completable future and different methods and things. Okay, I wanted to complete the logs today, but okay. Monday I have to go to office, so my Tuesday we can end this thing now. So alright, so why to use completable future? Okay, alright, okay. I haven't started, right? Okay, so no one has the prior knowledge of completable future, right? Okay, we are in the completable future itself. Alright. So basics, then I will create in the package. See, what's the difference? See, executor service also runs in a thread pool, right? And if we write the completable future, okay, I'll show it. Okay. uh, 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 functional 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 execution, functional introduction. All right. Okay, basics, and okay, it should be inside the basic itself. Okay, function introduction are cool. So all right, so let's add few things. So multiple, see the workers, right? Different worker, different worker, different worker, runner. So what I'm going to do right now is simply create a task, and let's say runnable we are taking, because we don't want to return anything, right? So we should know when to use which one. So hello greeting task, right? Greetings from, and then thread dot current thread dot get name, right? Greetings from this, and we'll do the completable future, return the sync, and then task, and 1 2 3 4 5. Cool. So if I run this, no, okay, my bad. So see, completable future is daemon, right? So we need to make sure that I have non-daemon thread, right? Okay, not current thread, shit, my bad. Main thread is a non-daemon thread, right? So a non-daemon thread should be alive. So I will make my non-daemon thread, which is the main thread, to be waiting for 5 seconds. So it will wait until my non-daemon threads, which is this, it gets executed. See, greeting from, now you will see it is also using a pool, right? Fork and join pool. So over here it has created 1 2 and 3 workers only, right? And then the second worker again used twice, visible.
Yeah.
So it internally creates a thread pool, right? And it uses it again. So now you are not even forced to create your own thread pool, right? It will manage on its own. In the executor service you need to mention, right, whether you want fixed thread pool, you want cache thread pool, and the way the executor works is you need to mention how many threads you want, Then there are different implementation, whether the threads will be created based on the demand, whether the thread will be created as soon as the object of the executor service is created. So that thing is with the executor service, right? You need to mention how many threads you want in a pool. Over here, have you mentioned anything? No, right? Still we have workers, and still we have workers which has been reused again and again, right? Workers is nothing but the threads. In the computable future terminology, it's called workers. Cool. So one benefit is we don't even have to now take care of the pool systems, right? We don't even have to know whether there is some design pattern of pooling concept and whatever it's thread. So there, we don't need to know about the thread pooling concept. We can directly use it, right? As many abstraction layer we can add, that much the things is better for a fresher to work with, right? For a for a person with expert level, we need to know a lot of stuffs. But for a person with the beginning level, your language should be way too easy to work with. With completable future, it becomes easy. The only thing that you should know is the daemon thread concept. That okay, otherwise if I remove this, there might be a chance I'll get not a single answer, because before anything over here will work, the main thread will get completely over. So that's the only thing. So it has an abstraction over the thread pooling concept, right? It will handle on its own. What's the next thing? The next thing is that we have been using from the very start. It has provided that lambda usage, right? In the 8th version itself, lambda has been introduced. So when it was introduced in 2005, executors was also unable to handle the lambdas, because lambdas was not even there, right? How can they handle it? So lambdas, it has provided us the function programming using lambdas. Now what's the another thing that has been provided by executor completable future that was missing from what we are comparing? Executor service, right? So what was missing from executor service that has been provided with the future not futures, this completable future? Anyone want to answer?
Supplier.
Okay. All right, supplier we already covered, right? Great. Anything else? Okay, just for fun, can I use supplier with executor service? Okay, how would you know? Cool, no worries. Okay, let me just write it. Executor service, and executor service equals to executors dot new thread pools 3 executor service dot submit. You will see Runnable and Callable, right? There is no scope for suppliers, right?
Acha. Okay.
Okay, so nothing, it's just simple. Sometimes what I have seen people trying to pass supplier into this thing, you can into the executor service. What you can do, you can create a completable future and then put it to the executor service. That thing is possible. All right, then computable feature, what will do, it will execute by using the thread from the thread pool that has been created in the. All right, just give me 1 second. All right, move. All right, just give me 1 second, I'll be back. Please. Okay, just 20 minutes more. And okay, let me just check whether the recording is on. Yes, cool. Let's go ahead with the completable feature, right? So this was the one way, one thing that's with the completable feature. But the supplier thing is there, that we know that supplier cannot be used with the executor service. It can only be used with the completable feature, right? And okay, now the next things that we need to know about the completable features. So it has many benefits, and the first benefit is the results that we get. The first thing is the result that we get, or the data that we get. What can we do with those things? That's the first thing. And another thing is also there, if I want to return something, it becomes way too easy to work with and play with. So I'm going to write different examples way too fast, or should I write it in one single way? Okay, I will write okay, benefits, completable future, completable future. Okay, functional execution runner. Now you will fall in love with the completable future, even though it has a drawback that it's a daemon thread. Alright, so now what I'm going to do, I'm going to start with the completable future, and completable future is able to, okay, supplier. Now we'll work with the supplier. Supplier will be able to return something, right? We have already covered it. So let's call it a future only, and then completable future, and we are going to see run async is for runnable, right? And supply sync is for supplier. So now what I want our supplier is to return something which I can directly return. Let's say greeting, and let's say hola users, cool. So now I have a future which will return, eventually going to return hola user, right? So that's where I have mentioned. See, completable future is mentioned also, right? Future, we have also already seen future with the callable, right? So it's an advanced version of the future also, completable future. So now what I'm going to do with this completable future is simply I can print the result. How can I print the result? I can just do future.join, and what the future.join do, it returns the value, right, when completed. And the thing with this is it's a blocking thing that I just put the join, so it will not going to execute if, okay, hola user site printed over here, right? So let's suppose that instead of a single line, if I'll increase the number of lines in my supplier, okay, and just add, okay, it should return, and but before it, if I'll do thread.sleep for 4 seconds, and cause a don't throw exception, it will force me to write the thread.sleep, right? So now if I run this, what should happen? It's waiting, right? It's waiting for 4 seconds, and as soon as 4 seconds is complete, and then I get the result, right? So future.join is equal to completable future.join is equal to future.get or the normal thread.get, right? It will wait until the we get the response. Cool, clear till now?
Yeah.
Okay, so this is the one example, but I'm going to remove this thing, otherwise it's going to be okay, even I can remove this if it's the single liner, and okay, this cool, great, a simple line, right? So this was the first thing, right? Use join for making it non-blocking. Cool. Okay, non-blocking means code will stop there. Okay, current thread will stop there until result come from future. All right, so this was the first thing, right? Very easy, right?
Making it block.
Yes, this is a blocking. No. So the next thing is, if I want to get something, right? Let's suppose you wanted to fetch the price of a airline, right? I mean, you get a price of the airline, but you want to add your markup as well. Let's suppose the airline price is of 50 rupees, but you want to add your markup of 10%. You want to make sure that you earn 10% when you sell any flight, right? So what we can do is simply public static and int get air asia flight rate, return 1, okay, return 50. All right, or why to make so much fuss. I can directly also, okay, let's write this thing, and I want integer as the result as well, right? I want to write my markup as well, and the future object is there. Okay, future is already there. So flight price with markup. Cool. So what can I do? Normal this supplier async. All right. And what supplier async will do is it can directly return 50 as well, right? I can directly return 50 as well, or I can call this method as well. I mean, it depends how you want to use it, right? I'm using this thing. If you want to make it simple, you can just directly put 50 over here. So what AirAsia flight, what it will provide? It will provide the value 50, right? Am I right?
Yeah.
And if I'm going to print over here the future flight with markup join, what will happen? You'll get 50 directly, right? But do we want 50? No, we want markup. What is the markup? Let's suppose markup is of 10%. Markup is of 10%. Markup percent equals to 10. Right? Markup percent is 10. So there is another there is one thing that I can just do 10%, right, over here. This is thing, right? I mean, okay, wait, but I have to do one more thing. I have to add this thing, this join, and then okay, plus the markup, and inside the markup what I can do is flight price markup into 0.10. okay, get join. Cool. So if I run it again, now I made it 55, right? Visible?
Yeah.
So but how people usually do earlier, I mean, I have used the same thing. They used to put user get, and when they use get, they get the flight price. Right? Flight and the price, and you get the flight price, right? Okay, it's going to throw some exception, so I'm not going to handle it. So it throws. Okay, my bad. All right, let's get back. So now I have the flight price, so I will have the flight price over here, and what I'm going to do now, simply what I was doing earlier, flight price into the markup percent, right? Markup percent is 10. So if I run this again, the output will be same, right? Okay, 550. Why 550? Okay, 10. So let's do 0 point this. So now if I run this, okay, so if I did this, then it becomes a double. So markup is a double. So let's run this. So 55, right? Get the price 55, right? But what happened? I get the result, then I have added the markup, I have fetched the price, then I have added the markup. The thing that the complete process has been done in 3 manner, right? 3 way. Am I visible? And the code is visible, right?
Yeah.
Okay, so now see the beauty of this thing, completable future. Let's mark up and let's call it functional. So see what will happen as soon as I get something, the flight rate, right? Then what I'm doing, I'm adding the price, right? So what's the thing over here? You will see future. Okay, flight functional dot join, right? And this thing we are adding the markup later on, right? When I get the flight price, then I'm adding the markup, right? Then only
Yeah.
okay. So then apply and flight price plus flight price into markup percent. Visible? Okay, flight price is already defined. Okay, shit. Flight price. Okay, flight price. Okay, so what can do? I can, okay, variable name. Okay. Let's change this name. Static flight price. Static or flight price response. Let's change this variable name, flight price response. Cool. Now I can use it over here. Okay, now what's the issue? Completable future double. Okay, cool. Okay, no worries, let's make it double. And spelling is wrong, let's fix this also. Response, cool. Now the thing is, see the code and the beauty. As soon completable future, I have mentioned to do a task, right? This is a task, right? We have created a task using lambda, and as soon as I get the value from the task, I wanted to operate on the result of the task, and then I want to update the result of the task. Earlier, what's the difference between this code and this code? Can you please let me know what's the difference between these two codes? Okay, apart from that, we are doing this thing in 3 lines and doing this thing in 2 lines. What else? The difference.
So we are avoiding story.
Okay, okay. See, what will happen over here? Also, we are storing it, right? For a little long. I mean, for a little period. Again, with the garbage collector has been optimized in 8, especially to work with the lambdas or the streams. So the intermediate object which is created is immediately garbage collected. So over here the flight price is similar to this flight price, right? But this flight price object will be deleted as soon as this method ends. But over here it needs to wait until the entire method ends, right? Then apply is will going to live a shorter life span than this int,
Sure.
because int will have this is separate thing, right? This is not based on this thing, this is separate thing. I just wanted you to know that over here also a variable is created, right? This is not the case. The case is over here you made your code not non-blocking by using it. Your thread will not move ahead until you get the flight price. If you have 1000 lines below it, your code will stop here. Let me run it. Okay, it was way too fast. The response was way too fast. Let me just add thread.sleep here. 5 seconds. Now, if I run the code again, Hola users, and we are waiting. We are waiting for 5 seconds to get this result. Then we'll move ahead, right? Visible? We made our code
Okay.
non-blocking over here. But what if I comment this thing? Okay, markup, I need to uncomment the markup. So if I remove this thing and write a line over here, after processing flight rate, right? So see, if I run this, okay, I have used join. Okay, my bad. See, the thing is, join is non-blocking here, right? And over here, the intermediate part was, okay, if I put this thing before join, if I run it now, you will see after processing rate, the intermediate part that I was doing over here, it was non-blocking, right? Is it visible?
It is blocking. Unblocking. It is blocking.
Yes, it is blocking. This code is blocking, right? Because I've used
Okay.
get. Now the thing is, because intermediate part that I was doing was a blocking operation. So but over here you can see that this line was executed before even this line. 55, before 55 this line is executed. So the intermediate part that was blocking, right? Intermediate part that was blocking, you put it into the method chain and you made it into unblocking, non-blocking part, non-blocking code. So that's the beauty of this.
Achha.
That's the
Okay.
one thing. And we're going to see a lot of things over here. And the thing is, you don't need to know it upfront. You will do it and you will know it. It's not like on the very first day I was aware of these things. If you work with it, you will know it, right? But the thing of this class that we are doing today is not that you will able to know this. I mean, it's obvious that if you're going to appear for the interview, you will cover the basic first, right? And that should be a goal also. But the thing is, if as soon as you are discussing with your manager regarding the design, you should know that which are the things which is possible using the Java 8 version, right? And 17 is free right now, so everyone is on 17. So obviously 8 feature is already there. So yeah, okay, so that thing is done. And now what we can do is, I mean, there are many things. Let me just put one more, right? We can cover those things later on if we have the bandwidth. So all right, what should I do now then? Okay, so let's see one more thing. Okay, so what we can do is we can write two tasks. So let's suppose there is a task one, runnable runnable task. And what's the task? Okay, let's take an example of, okay, let's take the example of the thing that we have already done today, the cola factory example, right? So let's say that, okay, we have fetched, okay, my bad, okay, procurement task, right? So create and pack, manufacture and pack the chips. Cool. And what I'm going to do is I'm going to put it inside the sysout, right? This is my first task, right? Then my next task is to distribution task, right? So sysout started distribution of the chips. Cool. So for this, till now we have worked a lot, right? We have worked a lot for this, right? Till now, that our procurement task should get complete, then only our distributor should work. And we have used thread.join, we have used the latches, we can use barrier also, but that's a different thing. And we should not use the barrier in that case. Latch is the perfect example to use it. And we can use the semaphores, whatever the alternative is of the latch, we can use that also. But the thing is, it will become way too easy if I'll just say let's do procurement task and then run distribution task. Visible how much easier it is if I run this after processing, right? Okay, why it's waiting? Okay, for 55 seconds waiting. Manufacture and pack the chips. Okay, spelling is wrong. Manufacture. Okay, create, let's say create. My brain is not working properly. So cool. So it is waiting for here. I think I have used some thread or sleep here somewhere. So let's make it a single second instead of 5 seconds. Let's run it again. Okay, create and pack the chips and start distribution, right? So it has become way too easy, right? Run something and then run something. Run a task, then run another task. Visible?
Okay.
And it will not stop here. Then run some another task, and then run some another task, and then accept something, then only do it, and then apply something, then do it, and dot, then run something. So it's a complete change. The functional programming has been introduced with the multiple threading that was long missing from the executor service. See how much easier it has become, right? Even a fresher can also work with it now. Got it? Okay, let me put the example back. Okay, with only two things, so it becomes way too easy to work with the things. But the thing is, we should know why. I mean, now you must be thinking, right? It's way too easy, right? Why we have seen all those things that we have seen till now? The reason is we should know what is runnable, right? We should know this is lambda. We should know how the lambda is created. We should know the history of the lambda. That okay, so as first full classes were there, then we move to the anonymous classes, then we move to the lambdas, and lambdas can be worked with the completable feature. Because to know this, it's way too easy. Everyone agrees with it that it's way too easy to know. But we should know the alternatives also. We should know why to use it, why not to use it, benefits, drawbacks. So this is just a tip of the iceberg, right? Completable future has so much things to work with. I mean, whatever you can do with the non-functional, with the combination of functional style coding, along with auto handling of thread pools along with working with different tasks, that is the suppliers. And okay, one thing, completable future, does it completable future work with callables? The answer is no. You can only supply a sink, or you can run a sink. All right, only two things. It cannot use with the callable. Completable
Okay.
future don't work with the callable. All right, and I don't know whether we'll be able to say it or not, because there are way too much things to work with. So see, in that thing that I have mentioned, that you can add the callable feature with async, right? So you can add a task, and you can, okay, there is no task. Okay, let's add procurement task. All right, and then okay, executor service equals to executors that new fixed thread pool, let's say 3, and then over here I can pass the executor service, right? Visual. So that's how we use combination of executor service with the completable future, right? Why we need to use this? Because completable future is daemon threads. And why executor service? Because executor service, we are forced to close it, right? We have to eventually shut down executor service. All right, till then an executor service is a non-daemon thread. So it makes sure, if we are using in this manner, we made sure that our tasks will get executed. All our non-daemon threads which we have created using the completable future will also get executed. Clear till now? So there are way two benefits of this. There are way two benefits of logs, but we will not be able to cover all this, right? You will learn on your own at your own speed when you are working with it, right? My job is to just let you know that these things can happen with it, right? All right, let's end the session today. Okay, if you have energy, we can continue with the logs.
Yeah, we can. Some
Okay,
10, 20 minutes.
okay, other people also agree, can we continue? Okay, if no one respond, then I will treat it as a yes. All right, Dikshita and Vinod, is it cool if we go ahead with the logs also?
No. Okay, okay.
Okay, are you saying yes or no?
Yeah, I am saying yes.
And Dikshita, are you okay with it? Half an hour or 1 hour more?
Yeah, yeah.
All right, great. Okay, let me just stop